Alright guys, so today we're going to talk about absolute values. This is going to be our first function that we're going to be digging a little bit deeper into. Okay. Today all we're going to talk about is the absolute value function equation, the basic equation, and what that looks like when we try to graph it. Okay. So let's first start with what is absolute value. Okay. Absolute value just describes the distance a given point is from a center. Okay, so usually we deal with positives and negatives just tell you which direction to go on the number line or the axes if you're plotting a point. Okay, so you can see in my example here the absolute value of 6, these absolute value bars are how we denote absolute value, is equal to the absolute value of -6, which is equal to just 6. Okay, so when we take the absolute value, what comes out, what the output would be, is the distance, in this case, from 0. Okay, so you can see right here that both +6 and -6 are a distance of 6 from 0, hence why they are both equal to just 6 without the absolute value bars. Okay, now when we want to look at the equation for an absolute value function, it looks a little different. Okay, so here's our basic equation. F of x and x are still there. F of x is just our output. X is what we're going to use for our input. And then there's all these little extra letters, A, H, and K. Okay? A acts like slope. It's the rate of change in our function. So if you remember y equals mx plus b, A here is our new m. Right? And then using this slope, we will usually find the vertex before we plot it, and the vertex can be found with these two letters here, H and K. H is always inside the bars, okay? K is always outside the bars. And H just represents the x value of what we call the vertex or turning point, and K represents the y value of that vertex. You can kind of keep in mind that the x value of the vertex is in the bars with the x. The y value of the vertex is away from the x, outside the bars. Okay, so this equation is actually quite helpful. It can not only tell us exactly where our turning point is using these two numbers, it can also tell us the rate of change in any given direction, either left or right. Okay. Now, what does this mean? Here's an example of an absolute value function. F of x equals 2 times the absolute value of x minus 4 plus 2. Okay? Now, if we wanted to plot this, first thing we would do is find the vertex. Okay? The vertex here is at 4, 2. What you need to do is you need to find the opposite sign of the number that's in the bars, okay? If you look back at the equation, you'll notice it says minus h. That minus sign inside the bars is telling you to take the opposite of what h is. So instead of my vertex being at -4, my vertex is at +4, okay? And the 2 outside the bars, again, you'll notice here in the original equation that it's a plus. That's telling us to keep the exact same number. We do not have to switch that one, okay? So inside the bars, switch it. Outside the bars, keep it the same. So this equation is telling me that my vertex is at 4, 2, right here. 4 over and 2 up. And the number in the front, the 2, is telling me my slope, okay? If you remember from y equals mx plus b, slope is rise over run, okay? If it's a whole number, you can always write whole numbers as that number over 1. So this is telling me that from my vertex, I'm going to be going up 2 over 1. And you can see that. To get from this point to the next point, I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. And you can keep doing that all the way up this line. Now, if we wanted to get the other part of the absolute value little v here, we'll go back to the vertex and then we go up 2 over 1, up 2 over 1, okay? So that is how you would graph a absolute value function. Let's take a look at an example that I have here. Okay, so here I have the function g. G has the input value of x here. Okay, so what we're going to do is we're going to plot this graph. First thing we need to do is find our vertex. Notice here it says plus 4. Well, we're going to take the opposite sign. Okay, so our vertex is actually going to be at 1, 2, 3, 4, negative 4 in the x. And then outside the absolute value bar, we have a negative 2, a minus 2. This one's going to stay exactly the same. So this is telling me that my vertex is at negative 4, negative 2. Okay? We already made our first point. To tell you the truth, all we really need is 3 points for this graph in order to completely graph it. Okay? And that's thanks to me using the straight edge. So our next point that we're going to find is going to create the right part of our V. And I'm going to use this 3 to help me with that. Remember, our slope is rise over run. Here my slope is 3, so that is 3 over 1. I'm going to be going up 3 over 1 from my vertex. Okay, so we're going to start at our vertex. We're going to go up 3, 1, 2, 3, and over 1. And with my handy straight edge, that's all I need to do. Because I can connect those 2 points, and I can make it go up as high as I want. Okay? If I wanted to, I could continue to go up and over and find another point. Up and over and find another point. Okay? I would just keep going up 3 and over 1 every time. Now, this doesn't exactly look like our absolute value function, because our absolute value functions look like those big V's like we saw before. So if you want to get the other half of your V, you go back to your vertex, and you go up 3, and now instead of going to the right one, we're going to go to the left one. And I can continue to do that if I really want to. Once we connect those, boom. We have our absolute value function with the vertex at negative 4, negative 2, and the slope of 3. Okay? So I'm going to have you guys answer a few questions and see if you can't figure out a few graphs given an equation. Okay? All right, guys. Have a good day. I'll see you all later.